to clarify a few steps that need to be taken when calculating the specific heat capacity of oil in laboratory settings. So this is how the diagrammatic representation of the setup of the equipment would take place. You'd have a DC source here of about 12 volts or 9 to 12 volts, followed by an ammeter and a voltmeter in parallel, along with a resistor, and this resistor component shall be used to heat the oil. And you'd have a diode, reverse forward bias diode, to ensure that the electric current is pushed in one side only and not reversed, and so it increases the efficiency of the transmission of currents. So we would need the following components. The first one would be a couple of thermometers. We need 2 thermometers to verify that the temperature change is uniform in all sides, along with the anti-bumping granules here at the bottom. So the anti-bumping granules shall be placed at the bottom so that when the oil boils it doesn't spurt out, and these anti-bumping granules balance out the internal friction and viscosity and the drag of the oil when it's undergoing heat, undergoing temperature change, and the kinetic energy of the oil molecules is increasing as a function of time. So we need the circuits components to be set up in real time, and we need a couple of thermometers, lots of glassware, lab glassware such as flasks, graduated cylinders for volumetric transfer to calculate the upper meniscus, lower meniscus, i.e. the volume and the mass. And then we also need a voltmeter, an ammeter, a forward bias diode, along with 2 timekeeping devices on either side to compensate for and measure time and compensate for the parallax, as well as human reaction error or systematic error. Then the person conducting the practical shall need PPE, personal protective equipment, such as tying the hair back, not wearing any heels, wearing gloves, using safety mat, and using kitchen mittens to handle hot equipment. So after having taken the safety measures, this is the equation we'll be using to calculate the C, or whichever of these is the unknown variable. So we've got the voltmeter voltage, this is the voltage, and yes, we have a DC source here, but it'll be going around. We have to measure the voltage across the ammeter. That's the voltage being used by the coil to heat up the oil, because there's a thing called EMF, and V equals IR, I capital R minus I small r. So we have to ignore the small r and just focus on capital R, and that's and that can only be calculated when you've got a voltmeter in parallel to ammeter. So once we've done that, we've got the current, the voltmeter, the average time, and the average temperature, the starting temperature, the final temperature, and we've got the volume, and we know the density of the oil. We can then find out the specific heat capacity of the oil in joules per kg per Kelvin, and that would be a successful completion towards the calculation of specific heat capacity of oil. And I think that would be quite useful, and it's practical, used for triple award GCSE and AS level physics. So I hope you found this video useful, and please take a screenshot, and please feel free to print it off after cropping the screenshot, and I hope you'll find it useful for your scrapbook. Thank you very much. Take care. Bye now.